Our lesson today is polarity. So our learning target, I will analyze how the distribution of electrons in a molecule determines its polarity, and we'll connect molecular polarity to patterns in physical properties and interactions such as solubility and intermolecular forces across different substances. Okay, so right now we're just going to worry about identifying whether a a molecule is polar or nonpolar. Okay, so let's look at both of those cases. So we have a nonpolar covalent bond. Basically, it's a bond between two non-metal atoms, right? Because it's covalent, that have the same electronegativity and therefore have equal sharing of the bonding electron pair. Okay, so basically, if they're the same atom, or if they're in the same group, okay, they would be nonpolar. Okay, a polar covalent bond again happens between two nonmetal atoms, but in this case, they have different electronegativity and therefore have unequal sharing of the bonding electron pair. So in our picture here, we have hydrogen and iodine. They're sharing 2 electrons, okay? Iodine is more electronegative, so it's going to have the electrons longer than the hydrogen does. So it becomes an uneven when it comes to like if you think of poles on a magnet, right? It becomes uneven. So one becomes more magnetic than the other. Okay. Okay. One way to tell if a substance is polar or nonpolar, only substances of like polarity will dissolve in each other. So oil and water, right? They don't have the same polarity. So this is water. Water is polar. This is ibutane, which is the oil, right? And it is non-polar, right? Because the outside molecules, right? These outside pairs are all the same. Okay. All right. So here's the trick. First thing you need to do is look at your shape sheet. Okay. That's that sheet that each of you should have gotten from me. Okay. So if you check out your shape sheet, there's a column called polarity at the very end, right? So it's on the right-hand edge. Okay. So look at your shape. Okay. And here it says, if the end elements are the same, it's non-polar. So because I'm looking at carbon dioxide here, I have an O on this end and an O on this end. That makes it non-polar. If the end elements are different, that makes it polar. Okay? So if you read what's in the polarity column, it will tell you whether something's polar or non-polar. Most of them are polar, and then there's a couple that have can be one or the other. So you just have to read it. Okay. So to sum it up, I have a polar bond between two non-metal atoms that have different electronegativities and therefore have unequal sharing of the bonding electron pairs. a nonpolar bond between two nonmetal atoms that have the same electronegativity and therefore have equal sharing of the bonding electron pair. So polar, unequal, nonpolar, equal. Okay? Unlike polarities, only like polarities will dissolve in each other. Okay? If they're not both polar, they can't dissolve in each other. They'll just sit on top of each other. Okay? And then check your shape reference sheet to determine whether it's polar or nonpolar.